This video is to review Unit 9 homework questions. So the first thing that we're going to do is we're going to start on sheet 1 of the lake house. And we're going to look at the site plan. So I'm just going to zoom in a little on that. The question asks, what are the lengths of the north, east, and west boundaries of the lake house site? So in our previous chapters, we learned that this line right here is called the property line. This property line marks the boundaries of the site. Along the property line, you're going to see the bearing, which is this first number up here, and then the length underneath. Remember that when you read the bearing, it's telling you directional information. So this is north, 86 degrees, 5 minutes east. And then the length of this line is 100 feet. So now that we know that this is the property line, this is the bearing, this is the length, we need to refer back to our north arrow so that we can orient ourselves to the north side of the plan. So the first question, it wants to know the length along the north side. So north is pointing up, so this is going to be the north side, and our length would be 100 feet. The second question says, what is the length along the east side? East is going to be over here to the right. Again, we're going to look at the property line. Along the property line, we're always going to see the bearing and the length. So the length is 245 feet along the east. And then if we move over to the west property line, we see the bearing and then the length underneath, which says 261.3 feet. The second question shows you a figure of a compass in your book, and it's saying which of the compass points corresponds with the north boundary of the lake house. So again, if we're looking at the boundary, this is north, 86 degrees, 5 minutes east. So we're looking for a point on the compass that it's in the northeast corridor. So if we take a look at our compass, we'll see that C is in the northeast section of this compass, so that is the north. Now it also asks which compass point corresponds with the east boundary. So the east boundary is going south 3 degrees 55 minutes east. So we're looking for, we're going to be looking over here in this corridor, so then the only one that would make sense would be D. The next question asks, how many trees are indicated for removal? So if you take a look, so if you look on page 61, you're going to look under clearing the site, and if you read the textbook, it talks about trees that are to be removed and trees that are to be saved. So it says that when trees are to be saved, they're shown on the plot plan by a symbol and a note indicating their diameter, and then it shows the symbol in figure 9-4, and that symbol is this, and this is a tree that's to be saved right here. And then underneath it says that when trees need to be removed, they're going to be this hidden line, dashed line right here. So it's pretty typical in demolition that things to be demolished are going to be some sort of dashed line or hidden line type, so that indicating demolition. So remember that you have to read sometimes in your book in order to be able to answer the questions, and if you don't know how to find something, you need to go back through the chapter and read, because it's often telling you in the information. So anyway, the question says how many trees are to be removed. We're going to count all the trees that have this hidden line. So there's 1, 2, 3, 4, 5, and then we'll see if there's any more, and 6. Now you might want to highlight on your drawing because it is a little tricky if you can't highlight things. And there is a highlighting tool, I think, inside of here. Let's see. Now, I'm sorry, I lied. So go ahead and print it out and then highlight it as a print drawing. Otherwise, you might miss something. Question number 4 says, how many trees are to remain on the site? So we're going to count those trees. Again, they're the circle with the crosshair through them, and that indicates remain. So we have 1, 2, 3, 4, 5, 6, 7, 8, and 9. I don't believe I counted that one. So there's 9 total trees. For question number 5, it says, what is the finished grade elevation at the tree nearest to the lake house? So in order to do this, you have to find out which tree is closest to the lake house. So you're going to want to use the drawings that came with your drawing pack so that you can scale them. So the scale of this is 1 inch equals 20 feet. You're going to lay that scale so that you measure from the edge of the house to the trees to find out which tree is closer. So we see that we have a 24-inch oak and a 10-inch maple, excuse me. They're both approximately 12 feet from the house when I measured them. And then if you take a look at where they're sitting on the contour line, it will help you to know the elevation. So if I read, let's look at the 24-inch oak first. So if I read this contour line, which is the proposed, you have to find which number this is at. So it's at 336 feet. So you can see it right here. It's going in 336, ends 336. And then the 10-inch maple right here is not quite at 336 feet. It's between 334 and 336. Okay, so you could interpolate that, or we could just call it 335 point, let's say 7. Number 6 says, what is the natural grade elevation of the most easterly tree to be saved? So again, you have to know from your textbook, if you look on page 63, figure 9-7, it indicates that the dashed lines are the natural grade, and then so that's what we want to look at right here. So these dashed lines are going to be the natural grade. So we're looking for a tree that's all the way to the east, and we know east is over here, and it's a tree that's going to be saved. So we see a 24-inch oak right here, and it's between 2 contour lines. So it's between 328 and 330. So we're going to have to interpolate to be able to say what the elevation is there. So to interpolate, you need to go to page 63 and take a look at step number 1. So step number 1 says to scale the distance between the 2 adjacent contour lines. So I'm going to zoom in a little bit here. You're going to have to use your drawing set that's printed, the packet. You can't do this off of the screen or you won't get the right numbers, but I'm just going to try to show you on the screen here. But if we're using this 24-inch oak, what we need to do is measure the distance from this contour line to this contour line using the 20 scale. So when I did that, I found that this is an 8-foot distance, excuse me. And then the second step is to scale the distance from the unknown point to the nearest contour line. So we need to scale that distance from, I'm going to go from the center of the oak to this contour line, and that was 4 feet, and the center of the oak to this contour line was also 4 feet. So we have, next we're going to multiply the contour interval by the fraction of the distance between the contour lines to the unknown point. So first you have to know what your contour interval is. So to know that, you have to look over here. So that it's going from 328 to 330. So, and that's going from 330 to 332. So the contour interval is 2 feet. It's going up by 2 feet, right? 2, 4, 6, 8, 10. So our contour interval is 2 feet. Now the fraction of distance between the contour lines is going to be the 4 feet that we scaled from here to here over the entire length that we scaled between the 2 contour lines. So we're going to have 4 over 8, which can be reduced down to a half. So our fraction of a distance between contour lines is a half, and we're going to multiply that by the contour interval, which is 2, and we end up with 1 foot. Now step 4, it says if the nearest contour line is below the other one, add it to this. If the nearest contour line is above the other one, subtract this amount. So the problem is that our oak tree was equidistant from both of these contour lines. So what I'm going to do is I'm going to add 1 to this 330, and I'm going to say that this oak tree is at 331 feet. Okay, and then just so you can see the math, I wanted to write it out for you. So we measured the distance between the two adjacent contour lines, and we found that to be 8 feet. I'll bold it so we can see it. Then we measured the distance from the center of the tree to the contour line, and then the center on the top and the bottom, and it was equidistant. So they were both 4 feet, excuse me. And the contour interval we said was 2 feet. And then the fraction of the distance between the contour lines, again, this is where you're going to take the distance from the unknown point, the 4, and you're going to put it over the distance between the adjacent contour lines, which is 8, and that's reduced down to 1/2. And then we're going to multiply that 1/2 by the contour interval. So it's going to be 2 times 1/2, and we get 1 foot. And then we're going to add the fraction of the distance. So we're going to add this 1 foot to the closest contour. And since they were equidistant, we're going to add it to our 330 foot contour plus 1 foot, and then we're going to get 331 feet. Okay, and I'm just going to stop the video here before I start question number 7, because we're going to have to do some more intense math and I'm going to run out of time.